Okay, awesome. So this is going to be exploring C# 8, the technical deep dive. We're going to look at all the amazing new features that C# 8 has to offer. My name is David Pine. You can follow me on Twitter at DavidPine7, and I maintain a blog at davidpine.net. Hopefully you'll check out both of those, where I'm constantly active, trying to give back to the community in various ways. C# is one of my passions. I've been following it for a very long time. And I was very fortunate last year to travel to 3 different conferences in Serbia where I got to speak about C#. So it's like my first international speaking stuff ever. Super exciting, super passionate about it. Hopefully you like C#. Just show of hands, raise your hand if you like C#. Okay. A couple people were like, are you Java developers or what? No. Okay. So there's a few bits of housekeeping here, some notes from Microsoft. So most of the features that we're going to that shipped as part of C# 8 are entirely reliant on the C# compiler. So that's a good thing, because the C# compiler is going to enable those features to light up when you get like the latest IDE, Visual Studio 2019, right? But unfortunately, there's a few of them that actually require .NET Standard 2.1 or .NET Core 3.0. And those were some underlying CLR changes. There were some new types that were added that are required for those features. And sadly, one feature is only going to be part of the CLR for 3.0 .NET Core. And that's the default interface implementations. So, and it's actually not going to be delivered as part of the .NET Framework 4.8. So just a little bit of housekeeping, kind of let you know. If you do get the latest and greatest Visual Studio IDE, show of hands, who's downloaded it? Couple? Who's hesitant? Anyone? One person? You admitted it. That's good. That's being honest. Okay. But if you get the latest IDE, and you can actually go to the advanced settings of your build config and say, in your properties page on your project, and say, target C# 8 as your language. So async streams is one of them that required some of the new .NET Standard and ASP.NET or .NET Core app. So there's some new types that I had mentioned. These are the types: the iAsync disposable, iAsync enumerable, and iAsync enumerator. And it's a pretty cool new feature, async streams, but those new types are required. A bit of housekeeping also is the ranges. We're going to get into what those actually look like, but those require a couple new types: a system.range, a system.index. So let's take a look at default interface methods. A lot of the stuff that I actually have is going to be demo code using Visual Studio 2019, but there's a couple things that I can't actually demonstrate because I don't have those, the 3.0's CLR updates yet. So for default interface methods, imagine that we have a simple interface, a public interface, iData repository of T. So it's a generic, and we have a simple method on it, void create, given that T type, right? Pretty straightforward C#. So now, as it stands today, if we want to add functionality to an interface, what would happen? It would break anyone who is an implementer of that, because they would have to take on those new things, and they don't necessarily want to opt into that, right? So that could be problematic. You might be introducing breaking changes. So we want to add a create all that takes an array of T, an entire collection of these objects. So with C# 8, with default interface methods, we can actually express functionality, right? So we can say in our interface, again, this is an interface, we can say create all as our interface, and we can express functionality. Notice how we're calling into create, a method that already exists on our interface. So this is the default interface method. This is what the default behavior would look like. And that's what C# 8 is going to offer, some cool methodology. Java has been doing this for years already, by the way. So anyone in the crowd likes Java? I keep picking on Java. Sorry about that. So another thing that we have is target type new expressions. So we have a simple class here, point. We have an x and y, and we have a constructor, right? So given x and y, This is some cool syntax that was available to us from C# 7. So this is not part of C# 8. But we can express our constructor if it's simple enough. Right here we have a tuple that we're assigning into our instance properties of our class. And we're assigning them from a tuple literal, right? So we can express that in a single line, which is pretty cool, right? So we have a simple class. We have another cool method, a deconstruct method. We'll get into more of what that is and how that works later on. But it's a deconstruct. It's kind of a magic method that lets us walk up to any class, not just a tuple, value tuple type, and deconstruct it into a tuple variable. And then we have an implicit operator. This has been around for a very long time. This is not new. Who's used the implicit operator? Show of hands, a couple people. Okay. So what it lets us do is basically say we're going to return a point given a tuple that looks like this with an x and a y. And then we can instantiate, express that as a single line as a new point given those two arguments, right? Back to our constructor. So with target type new expressions, this is what it looks like today, right? We have point, array, points equals our collection of new points. So what they're proposing is that we can just remove the type, right? If the declared type is point array, it's kind of redundant for us to say new that type because it's already targeted. We already know what it is. So that's kind of clever, right? It looks kind of cool. One thing that exists today already out of the box is with the implicit operator, we can actually, if we provide the type in our instantiation there on the right of the assignment, we can just say no new and no explicit type, right? So I'm just showing you like the different ways, the different ways that you can do that. I'm going to go back and show you. So here's today, here's the future with C# 8, here's something that you can already do today with C# 7, right? Pretty slick. Can you see this being useful? Yeah? Yes? No? A couple people? Pretty nice. Who likes writing verbose code? I have a general question. I just want to pick on the usage of var versus explicit typing. Does anyone like the var keyword? It's okay to admit it, yeah? Does anyone like being like super explicit, like dictionary, string, comma, a dictionary again because you have, your values are dictionaries, and then inside there you might have a dictionary of dictionaries. Some people like that? I don't like that. All right, so C# 8. This is where the bulk of our time is going to be spent. We're going to walk through all the various features, and then I'm going to give this a screen here a second. If you want to take a picture of this bit.ly, this is where all the source code is going to reside that we're going to look at. And I'll share them at the end too, just be prepared. Okay, so I'm going to fire up Visual Studio 2019. And I'm going to do it such that I'm just clicking on the exe to run, right, from the taskbar here. And you'll notice one thing, Visual Studio 2019's changed a bit. They have this new startup functionality. So rather than opening up the full-blown IDE, one of the ideas and complaints from most common users was it takes too long, right? Visual Studio takes too long to load. It's kind of cumbersome. Like, I just want to do something simple. I want to go to, some of my recent stuff, click on it and go. So this is an improvement that they've made with Visual Studio 2019. So one of my most recent projects here is C# 8. So we can click on that, and it should load rather quickly. It's a small project. There's not a lot in there. But this is Visual Studio 2019. We can applaud that. That's amazing, right? It's the best thing ever. I recently had learned about some of the complaints with Visual Studio 2019. Has anyone been following, like on social media and Reddit and Hacker News and all the complaints about the title bar? Anyone heard this? Couple. Just the one Microsoft employee in the back said yes. So I'm just going to segue out of that and not let you guys know that there's complaints about it now. But you'll notice that the title bar is gone. It's different now. There's been some complaints about that. Some of the community people were like, hey, I have lots of instances of Visual Studio running. How do I know which one I'm using? And I mean, there's still stuff, you get your solution name up here. For Windows, you get, when you hover over, if I hover over, you still get, like your little glimpse of what solutions are there. So it's not really a problem. It gives you a couple more pixels on the screen, so that's kind of nice. So I have a very simple C# 8 console application. We're going to start by clicking on the properties. I want to show you this. So if we go to application, from within properties, oops, 300 is too much. If we go to application, we right-click on a project, and we go into the properties of that project. You'll see, oh, my magnifier is right in the way. You'll see down here at the bottom that we have this Advanced button. When you click on Advanced, it's going to open up Advanced Build Settings. And this is where you get to selecting the C# language version that you're targeting. Now, one thing you're probably not going to do, I've done this before because I like playing around with the language, you're probably not going to select ISO 1, right? This is going to be like the first version of C# that shipped. Before it was, or actually after it was Cool. Do you guys know that C# was originally named Cool? That was like one of the names they were thinking about. It's a pretty cool language. So ISO 1, ISO 2, all the way up, you get the point releases of C# 7. And then this is where we get into the beta of C# 8, right? So we're going to select C# 8. Ta-da, we are all now officially C# 8 developers, right? We hit save, and it's amazing. So we have a simple program with the main entry points. I'm using John Skeet's demo utility. Anyone know who John Skeet is? A couple people. I like to think of him as being the world's most famous C# developer that is actually a Java developer. He works for Google. He's a Java developer there. But he's recently surpassed 1 million reputation points on Stack Overflow, and he was just recently appointed as a board of directors for the .NET Foundation. So he's got this little demo utility, which is super cool. It lets us do some cool stuff to run our application here. But before I start running it and showing off stuff, we're going to dive into async streams. So if you recall, async streams needed a couple various types. So we're going to start looking at this code, and this is where we're going to spend the bulk of the time. Before I continue on too much, I wanted to ask if this font and contrast is okay, like the size and everything like that. Everyone can see it well? Yeah? Good? Okay. So we have a main entry point. We're going to instantiate a stopwatch. And we have this cool functionality that lets us walk up to a get statements async. It's basically just a function that returns an iasync enumerable. And notice that the syntax has changed such that we have an await keyword in front of our for each, right? So typically you couldn't do that. You have to wait on your single async return type. So before we get into that actually executing and what that looks like holistically, let's just take a look at some of the code beneath. So we have an internal struct, which is a statement, simple, basically just a property bag. And we have a function that returns an IEnumerable of statements, so get statements. And we can just yield return. If you're familiar with C#, you're familiar with the notion of deferred execution. So with C# for a long time, since LINQ and whatnot, we had this notion of IEnumerable returning types. And if you use the special keyword yield within that, it's not going to actually execute. You're basically marking that method as deferred execution. So if this method was to come in and I say true to throw an error, and we invoke that method, nothing will actually happen. It won't happen until you materialize that IEnumerable, right? If you say .toArray or .toList or you for each it, that's the only time that exception will actually be thrown. So that's cool. And then imagine that we have an async version of it, right? So it's simply just returning a task of IEnumerable of statements. That's pretty slick. But enter C# 8, where we have the new type IAsync enumerable. And we say get statements. And we're actually using the internal one here that was provided above. and we're going to for each it, and we're going to await. We're going to give it a second in between, and then we're going to yield return. So we're using both the yield and await keywords within this method, and it's unique in that it gives us both deferred execution and the potential for suspended execution, right? It's really, really powerful. So let's just run this real quick. I've got a stopwatch, so we're going to iterate over the return of that. We're going to await for each of those statements, and we're going to just console log it out, right? I'm going to pick 0 for async streams, and you'll see within a second between each of those, we're logging out, right? So it's, again, it's the potential for suspended execution plus deferred execution, which is amazing. So it's, you get the best of both worlds. So this is another big one I wanted to talk about, nullable reference types. So as part of C#8, we get nullable reference types. And this is where your mind is kind of, if you're like me, your mind's going to be blown because you're thinking, what are they talking about? Reference types are already nullable. So how can we explicitly state that it's nullable, right? So with this feature, we're able to express our intent a little bit more, and we get some help. I like to think of it as like training wheels from the IDE that says, hey, you might be running into the billion-dollar mistake. Have you heard this phrase, the billion-dollar mistake? The billion-dollar mistake refers to the creator of null. He said it was the billion-dollar mistake because he should have never invented it. If you're a developer, I'm certain you've ran into object not set to an instance of an object, right? Null reference exception. And your mind is like, what is the problem here? Where do I have to go track that down? So with C#8, the promise is that they're going to help alleviate the potential for this concern. It's not 100%. It's not foolproof. You're going to still have bugs. It's not going to eliminate all this headache forever. So let's take a look at it. So one of the things that we can do is if we look at a simple person class, this is a common example, where we have a first name, a middle name, and a last name, right? What's really interesting about people is that not everyone has a middle name, right? So if we instantiate a person, we have two constructors here, one with first and last, and then another one with first, middle, and last. So that's fine. But if we were to dereference the middle name at any point in time, and that person wasn't instantiated with a middle name, what happens? Things go boom, right? You get your null exception or null reference exception. So what we can do is we can say pound nullable. We can enable this at the solution level too, but I just wanted to show you that there's compiler directives here. So we can say enable, and we can actually notate this string type, which is reference type. We can say now it's questionable, right? One thing I'll show you here is that the IDE starts complaining and says, hey, non-nullable property middle name is uninitialized, right? So when we enable this functionality, the IDE starts reasoning about your code, examining the reference types, and saying, wait a second, I can tell through static flow analysis that you have not done something we would expect. So you actually have the potential for a null reference exception. In this case, it's saying that something's not, it's uninitialized, right? So we don't have any way of knowing if this is set here in this instance because there's only a first and last name. So let's just say explicitly that we do want the middle name to be nullable. So we can append that much like we could with any nullable struct value before, right? We could say, int or date time, and we could add the question mark and make those questionable, right? Those are, those structs, everyone knows that structs are value types, and they're non-null, but we can, in C#, we could express those as nullables by saying question mark. We can do the same thing now with reference types to explicitly state our intent. Our intent is that the middle name of the person class can be null. Okay? With me so far? So if we were to instantiate Miguel here, and we're to have a method that says get length of middle name given Miguel, our IDE is going to complain to us and say, wait a second. Let me zoom in on this to make sure you can see. Our IDE is telling us that converting a null-literable or possible null value to a non-nullable type. You'll see that I'm going against my own suggestion, and I'm saying string. I'm explicitly stating that this is a string, right? And since I didn't say it was a questionable string, instead I said it was a var. If we wanted to go var, that would make it a questionable string. So now we have this nullable middle name, and we're trying to access the length property of that. It's going to tell us that we have the possibility of dereferencing a null reference, right? Through the power of the C# compiler and examining and looking at all the things that exist with how we've expressed our code, we have the potential for a null reference exception here. So since we've enabled nullable, our IDE lights up and tells us that we have the potential for that. So you can do this today. You can go over to existing projects, and it becomes fairly obvious all the potentials, right? All the potentials for where null might exist. So the IDE can help you, right? You can take suggestions and try to act on that, or you can do stuff like this, right? We can just say coalesce over to 0. So if this is actually null, we'll use the Elvis operator, and we'll say .length. So if the length is there, we'll get it. Otherwise, we'll coalesce over to 0, right? And then everything is happy. There is no potential here for this to have a nullable exception be thrown, right? So our code is perfect, right? Yeah? No? Okay. Maybe that was a stretch too far. It's better. It's fault tolerant. All right, so let's run that real quick. Nullable reference types. Bang! Miguel's middle name is 0 characters in length. Ta-da! Instead of blowing up, which would have been sad. So this one's really cool. This is what I get excited about some of this stuff. So pattern matchings. Pattern matching was introduced as part of C# 7. It's a super duper cool feature. I love what they've done with it. It was one of those things, again, that has some shock value, though, when you first see it. Because if you're like me and you write C# for your day job or for fun, like all the time, like I do, C#, you get used to how you write things. You get used to how you express your intent. So with some of these new features, when you first see them, you're like, whoa, holy cow. Like, I didn't know. Like, that's, it takes a second to kind of wrap your mind around. But you start to appreciate it with time. So we're going to dive into switch expressions first. I'm just going to show you the code. So we have a rainbow. Everyone loves rainbows, right? Red, orange, yellow, green, blue, indigo, violet. And then we have an RGB color, right? We've got the red, green, and blue. And we instantiate it like so, or this is the constructor, rather. And then we have switch expressions. So imagine we have an instance of this rainbow, right? So we could say rainbow.red, and we could walk up to it and say, from rainbow, give me the RGB color that represents that, corresponding value. And we would return new color with that, right? And that's amazing. This is how we write switch statements today, right? And that's okay. Imagine now with C# 8 writing it more expressively. Enter switch expressions. So taste the rainbow. This is where things get a little bit better. Right? So we can actually walk up to that rainbow color, and instead of saying switch and then the value, we actually say the value switch. Right? So the order is switched and there's no parentheses around it. So we say rainbow color switch, and this is the body of that switch expression. Within this expression, think of these as being like the individual case labels that had existed before, right? So we can say rainbow.red is expressed as the instantiation of the RGB color blah, right? It's the exact same thing, but instead of, what is this, like 10 lines of code versus more lines of code? Who likes writing more lines of code? Couple? Did you raise your hand for explicitly typed declarations too? Is that one of your things? So the other thing is we have this discard. This is a special, this underscore. You could use underscore before for naming various things in C#. If you wanted to just kind of ignore it, so the language actually adopted it as a proper recognized character, if you will. So this is, you'll notice it's actually underlined, it's blue if you were to zoom in and look at it closer. That's to indicate that this is just a discard. So if none of these cases match, we're going to throw an exception. Who likes throwing exceptions? We can talk later about that too. All right, so let's look at this. We've got an address class with some common properties: address line, city, state, postal code, country, region. Awesome stuff, right? So now we're going to look at property patterns. Within property patterns, it's very, very similar to the switch expressions that we were looking at before, but now we can examine individual properties within the object that we're switching over. And it gets very, very amazing. Like my mind's blown when I look at how cool this is. So given, we're going to compute the sales tax for an address, given the sales price. We're going to walk up to that location and say switch. And this is the actual expression. This is the case label, if you will. So we can say within our squiggly braces here that the address object, right, has a state property on it. So we can say if the state is Washington, we're going to do this for our sales tax. If the state is Wisconsin and the city is Milwaukee, we have this for our sales tax, right? Otherwise, we'll fall through, if it is still Wisconsin but the city doesn't match, we'll fall through to this case label. Otherwise, we can just simply say it's 0, right? Yeah, that's a great question. So the question was, does the break automatically? Absolutely. Yeah, this is not a fall through scenario. This is, each of these individual expressions are semantically equivalent to full-blown case statements that either have breaks or return in them. In this case, these are returns, right? Simply returns the evaluation of the sales price multiplied by 0.06, and it would not fall through. Correct. Good question. Thank you. Yeah. Yep, the order does matter. Yeah, that's a good question also. Thank you. Just like other switch statements that existed before in C#, order does matter. Yep. That's why I put the one that was more explicit up higher. So tuple patterns. Let's play a game of rock, paper, scissors, right? We've got the first rock, we got the second rock, paper, scissors. We can walk up to that tuple and we can switch on a tuple, which is amazing. I'm really curious, like who's been using C# 7? Show of hands. Do you use tuples? My God, I use them all the time now. It's like disgusting how much I use them. Probably because I hated like the system.tuple that had the awesome API for item 1 and item 2, right, and etc. That was great. Now we don't need to worry about that. So we can walk up to this. We're going to express the tuple as a switch expression. And we can say for these various cases, return this. And it's very, very, simple. It's clean. We express our intent. I think, in my opinion, this is a lot more readable in many cases than it was before. Like who's read ridiculously long case statement or switch statements that have had nested switch statements that have then had even more switch statements? You guys ever gotten into that mess? Just me? Okay. So let's look at a shape. We have a shape that's got a height and a width. We have a subclass circle. It's got radius, which is expressed as the height divided by 2, the diameter, radius times 2, circumference. Throw some pi at it. We've got a square, or actually we have a rectangle that is a square if the height and length are equivalent. So we have object patterns now, right? So before with C# 7 you could do this. Now we can do it with switch expressions as well. So let's get the details of a shape. So we have an extension method for the shape object. We can say it's expressed as shape switch. And if it's a circle, we have access to it within this expressive scope. Same thing if it's a rectangle, but then also it is a square, right? Notice how more explicitly we have that at the top because order does matter. And then if it's still a rectangle but not a square, we'll fall into this. Otherwise, we can just say we don't know what the shape is and discard it. Cool? This was the point class we looked at in some of the slides. Oh, yeah. Those are all subclasses. Yeah, the rectangle is a subclass of shape. Yep. But to your point, so the question was asking about specifically if these were subclasses or you know how the hierarchy was, and if this was just, imagine this just being a generic object, right? We can just make it an object. It would work the exact same way, right? Because everything is an object, right? So it just basically examines the type as a constant pattern within the switch label itself. All right, so we have quadrants because why not, for an example? Unknown, origin, 1, 2, 3, 4, or on the border. And then we have some position. So we have these points that we're going to look at, and I wanted to show you how we can actually switch on the points themselves and use positional patterns for our case labels, right? So if we are the constant tuple literal of 0, 0 for a point, we're the origin, right? But if we're x, y, we can declare our variable here and then say when x is greater than 0 and y is greater than 0, then we're up in the upper left quadrant, right? And see how we just kind of flow naturally and this works so elegantly. And again, I'm really passionate about C# 8, so get excited about it. But it's really cool, right? I think this is going to really help the language, and I think it's going to be allow developers to really express their intent more clearly. So let's just run this one real quick. Let's go back up to the top and see what we're supposed to be looking at. So we're writing a line. The first one's going to say switch expressions. We're going to show you the from rainbow given violet, and then taste the rainbow because red is better than violet. Property patterns. We instantiate an address, Wisconsin, Brookfield. We're going to pass in 100. We're going to show you what the sales tax is for Brookfield versus Milwaukee to show you that those are going to work. And then we've got rock, paper, scissors, some various outputs that will be displayed when we execute those. Object patterns, similar thing, right? We have a rectangle, 7, 7, so that should be treated as a square. And then our positional patterns, where we're going to say that here's a quadrant. We should end up in, I think, 2 based on that. So let's run that. Show you it works, show you it's real. Ta-da! So the legacy switch gave us this color representation. Red gave us red. Property tax. You know what's on my mind? Sales tax for Brookfield, which I spelled as Brookfield, which is nice. Milwaukee, the tuples, and we tie, and so on and so forth, right? Pretty cool. All right. So ranges. This is a fun little feature here. So I'm going to show you what this looks like. So with ranges, imagine that we have a words string array. And some of the cool things, you know, the quick brown fox jumped over the lazy dog, right? So we have indexes that correspond to them. If you've been doing software development like ever, you know, arrays are very, very logical. We think of them, you know, in C#, they're 0-based. So we know that each of these index corresponds to a string literal within this array. Pretty simple. As part of ranges, they're introducing the hat operator, which lets us walk up to an array and say hat 9. So from the end, right? So it's just a way of saying, instead of at the beginning of that array, we can start from the end and work our way backwards, right? So jumped, to get to that, we would say hat 5. But you'd also have to know the length of the array. So that kind of gets a little tricky. So it's just some cool syntax for how we can access things. So, oh, look, the IDE is suggesting to us a little fix here. So I'm saying the last word is words, and then we're saying the index is words.length -1. Who's done that logic before? Okay. So let's just go ahead and take this suggestion. Use the index operator. Ta-da! So we just walk up to the last one. We just say hat 1. So hat from the end of that index, whatever the length is, 1. Right? Pretty simple.
Do you know why that's 1 base instead of 0 base?
That is a great question. I do not. So one of the cool things, though, about C#, that's a good point to bring up. With C# 8, there's actually, it's all developed. C# now, the language holistically is developed in the open up on GitHub. So the language design team has meetings. They have proposals. They have, it's all out there. So you can actually help influence those decisions. You can be part of the conversation, and it's up on GitHub. But that's a good question. I don't know why. So would you have expected index 0 or hat 0?
It would make sense for like going from, it would make sense for going from start to be the same as going from back to the back.
Yeah.
So I would expect going from the back to the last one would be 0, just like going from start to the first one is 0.
Yeah, that's a good point. Cool. So yeah, the other thing is we can express ranges now as literals. So we can say, 1.4, and this will be the quick brown fox, right? And we can say we're going to write that out, string join with an empty space. So that is quick brown fox. So 1 through just before 4. And then we can also express, these are called range phrases, hat 2 ... as a literal. And notice how I put this, I explicitly typed it here so we can see what this is. This is the new type, system.range. This is a read-only struct. So when we instantiate this literal here, we have the last 2 of anything that we're going to walk up to, right? So this is just a range object. So range has a start and end members on them, and those are of index type. And index has is from end as a property, and then the corresponding value. So that's how they kind of structured indexes and ranges. So then we can say, let's get the last 2 words from here. We're going to get lazy dog. We're going to show that. We can just do ... if we want to get really cool, right? And just say that's everything, because why not? That's all of our words. Otherwise, we can get the first phrases here or the last phrase, right? See how you can just kind of intermix and mingle these up however you want. But that's basically ranges and indexes, and they're pretty powerful. Let's run this real quick. I'll show you that it's working. Ta-da! The last word is dog, quick brown fox, lazy dog, all the little parts that we cared about pulling out and logging.
How does last 2, where did you say last 2 is the last 2 characters?
Let's last 2. So that's the lazy dog. If we look at this array here, lazy dog is the last 2 values in that array.
You make it a range of last 2, when that range is...
Yeah, the range was up here. So it's hat 2 ...
Line 44.
Yep. Okay. All right, so static local functions. Who's used local functions? It's a feature of C# 7. A couple people. Local functions at first were, again, added a bunch of shock value. It was terrifying. I thought to myself, why are they doing this to my language? So here's an example of like the classic local function, right? So we have this variable int y, and we have a local function, and then we're returning y. Local functions allow you to actually express the function, that local functionality, anywhere within the method body, as long as it's local, even after the return. That's totally valid. But notice one thing that we're doing here is we're actually capturing, right? We're implicitly capturing the variable y inside that local function scope. And that might be concerning, right? So what they've introduced is a non-capturing version of that, which local functions now can be static, right? So if I was to try to reference x or y in here, it would blow up and say, you can't do that, right? We're static. You can't implicitly capture the scope of something outside of this local function. And I think that's a really powerful thing, because a lot of developers, even with Lambda expressions, will incorrectly do that today. And that can be problematic. And last thing here is the using declarations. So who's a big proponent of actually writing iDisposable code the correct way? No one's going to raise their hand? Come on, you're supposed to say, yeah, we all are, right? You use using statements then, right? So stream writer is obviously, it implements the iDisposable interface. So for the purpose of managed code, if there's a field within this class that's referencing unmanaged bits, you typically want to implement iDisposable such that when you dispose, you correctly then dispose of those fields to release any unmanaged stuff. It's like the proper pattern for C#. It's been around for a long time. And you can do that, try catch finally yourself and then do a dot dispose, or you can use it in a using statement, right? It's been around for a long time. So now what they're introducing with C#8 is implicitly disposing of variables within scope, right? So we can say using and then our variable declaration. We don't have to put it in a method body, right? So it can kind of reduce the lines of code. And then once it's done, down here, just before this method would actually exit, that will get cleaned up. The dispose will be invoked for you, okay? Pretty cool stuff. Now I have a general question. Would you, for the using one specifically, would you still be like innately afraid, like, oh my gosh, what if something goes wrong? Is my stuff going to be cleaned up? Because that's how I feel when I look at it. I'm like, wait a second, this just doesn't feel right. What do you guys think?
Yeah, I agree.
Yeah, you kind of feel scared. It's scary, right? Don't scare us. All right, I'm going to show you the static local stuff running. I don't think it even prints anything. Yeah, it's like we don't even have a thing there. About 5. Oh yeah, 5 doesn't do anything either. It's a no op. Okay, cool. We're going to go back over here. I'm going to close that. I'm going to do press more buttons. Press buttons. So quick summary is that we've looked at the various pattern matching improvements for C#. A bunch of things with switch expressions and how we can, make things more expressive, right? More compact, less boilerplate code, right? We don't have to have case labels anymore with breaks or returns. And we still get all the things that we're familiar with in terms of how we express our switch statements. Async streams. And to touch on this again, one thing I forgot to mention is a lot of people will typically ask async streams, like how are they different than RX.NET, or reactive extensions, the notion of observables. So observables and the iObserver pattern is pushed based. So typically you'll walk up to a stream of data and you'll subscribe to it and you'll provide an onNext. And that onNext is a callback. And you end up in what I like to refer to as callback hell. You do not have control. You can get flooded, right? You have no control over how many times you get called back, right? Whereas with async streams, it's the true IEnumerable method in that you're polling. Instead of being pushed to, you're polling. So as quickly as you are able to process that and then ask for the next one is how quick you can go. Nullable reference types, pretty cool, powering the IDE to provide a more potentially more error-free scenario. The new types for range and index, static local methods, implicit dispose, and using declarations. Default interface methods. Do you think you guys would use that one just out of curiosity? Yeah? Looks pretty cool. And then the target type new expressions. So here are the resources. This is basically the C#8 documentation up on docs.microsoft.com. We have some people here today from the docs team. They are sitting in back. Scott Addy, Mimi, I think that's it. But be sure to introduce yourselves, say hi, thank them for their awesome documentation. This is the one beneath that, the Building C#8. That is a blog post from Mads. And Mads basically kind of exemplifies all the latest thoughts around how C#8 came about. With that, thank you so much. And we'll take another 15-minute break or so. Thank you.